In this demonstration, I'll show you how to perform the substitution rule with integrals. This is part 2 of the series. As discussed in part 1, the steps for the substitution method are listed below. Now, oftentimes the hard part is figuring out what substitution to make. And this video introduces us to a few more examples that will allow us to practice this technique. Let's start with question number 1. In question number 1, they ask us to find the integral for the function 2x to the power of 3 over the square root of x to the power of 4 plus 1. So you have to determine what you will set as your u. And in this particular case, our best option would be to set this as our u. Let me show you why. U is equal to x to the power of 4 plus 1. What we have to do is differentiate both sides. So if I differentiate the left side, I end up with du. And don't forget the dx. And on the right side, you end up with 4x to the power of 3, and this goes to 0. The next thing that we'll do is isolate for dx. And the way we'll do that is we divide both sides by 4x to the power of 3, where we get du 4x to the power of 3 is equal to dx. Now notice that if I input this back into our function, we've almost accomplished one of our goals, which is to set the whole function in terms of x. Let me show you. So the integral of 2x to the power of 3, that's still a problem, over the square root of u, and now we have du over 4x to the power of 3. Notice that now that I've substituted dx back into our integral, the x to the power of 3 here and the x to the power of 3 over here cancel out. So let's do that. Let's cancel that out. And whatever we have left over, let's take it outside the integral. So we have 2 over 4 left over. Let's take that outside. That becomes 1 over 2. And we're left with du over the square root of u. So now it's a matter of finding the antiderivative of the square root of u, and that's not hard to do. Remember that the square root of u is the same thing as u to the power of half. And when we find the antiderivative, we have to add 1 to the exponent, and then you take whatever that sum is and you put it underneath. So the sum of half plus 1 is equal to 1.5. You take 1.5 and you place it underneath, except I prefer to work with fractions, so I'll use 3 over 2. And if I rearrange all of this, I end up with 2 times u to the power of 3 over 2 over 3. And I'm going to reintroduce this half, and if I do that, I end up with a third u to the power of 3 over 2. Now, instead of using u, we can go back and replace it with what we set it to, which was x to the power of 4 plus 1. X to the power of 4 plus 1 bracket 3 over 2. And since this is an indefinite integral, there are no upper or lower limits, we have to put a plus c at the end. Let's move on to question 2. Here we have to determine what to set our u to. And the only option that we have technically, because if we set that to u, it's not going to help, is to set x squared as our u. So let me show you what happens if we do that. U is equal to x squared dx. You derive both sides and you end up with du. This is differential calculus, is equal to 2x dx. We're going to solve for dx at this point. Dx is equal to du over 2x. Now notice what happens when I plug this back in. The integral of x sine u, I'm going to plug this in, du over 2x. Notice that this x and this x cancel out, and we're left with the integral of sine u du. It's in terms of u, and that's exactly what we want. The next step is to find the antiderivative of sine u. In previous videos, we learned that the antiderivative of sine u is equal to negative cosine u. So let's do that. Negative cosine u becomes negative cosine, and we're going to replace that u with what we set it to, and it was set to x squared plus c. And there it is. That is the antiderivative of this function. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at studyforce.com. We are an online service for students seeking free homework help. See you soon.